class. Now we're going to look at the next section, 4.5, which deals with exponential and logarithmic equations. So again, equations are something we can solve. Functions are something we can graph. So just real quick as a warm-up, if I wanted to rewrite 5 to the x equaling 9 as a log, well, this is base 5 in exponential form. So that becomes my base. And then it's of 9 equals x. So log base 5 of 9 equals x. Evaluate using the change of base theorem. So I could rewrite this if I wanted my base to be 10. So this would be log base 10 of 9 over log base 10 of 5 would be x. Or we can also write this with natural logs. Natural log of 9, natural log of 5. If we were to work this out, it comes out to be approximately 1.36, which would be good as approximation. If they said exact, then exact, leave it in the form of a log or a natural log. Next piece I have, how are log and natural log connected? Well, all a natural log is a log base e. So when it's not written, it's log base 10. Natural log is simply log base e. So we're going to do several equations to solve, starting out with exponential, and then we're going to move into solving logarithmic equations. And so I have about 5 or 6 examples at least that we're going to work through just to prepare you for the problems that will be on Math Excel. So if we want to solve the equation, 7 to the x power equals 12. Well, we know we can rewrite this with logarithmic form. So we could, let's say, log base 7 of 12 equals x. But let's actually use our natural logs to solve this one. So if I had 7 to the x equals 12, if I took the natural log of both sides, so as long as I did one thing on the left and do the same thing on the right, these remain equal. So I'm going to take the natural log of both sides. Well, now that I have natural log of 7x, I can use my power rule and bring the x up front. So this is x times natural log of 7 equals natural log of 12. Because it's x times natural log of 7, I can divide out natural log of 7 from both sides. So therefore, x will be in exact form natural log of 12 divided by natural log of 7, which is approximately 1.277. All right, but again, if I wanted exact, this is exact, this is an approximation. Let's go into one that's maybe a little more complicated, where we have an exponent now that is a function on its own. So 3 raised to the power of 2x minus 1, 0.4 to the power of x plus 2. Same thing, let's take the natural log of both sides. And again, we're doing it on both, so it's not changing our equation at all. But the reason we can do this now is we can bring the exponent down. So this is 2x minus 1 times natural log of 3 equals x plus 4 times natural log of 0.4. Now it's just algebraic manipulation. Again, we're trying to solve for x. So if I were to multiply, so I have a binomial 2x minus 1 multiplied by natural log of 3, so that becomes 2x times natural log of 3 minus 1 times natural log of 3. No need to write the 1. And then x times natural log of 0.4 plus 2 times natural log of 0.4. And so now we've distributed everything in. Let's move all the x's to one side because that's what we're going to solve for. So 2x times natural log of 3. And then we are going to subtract x natural log of 0.4. I will add my natural log of 3. So this is natural log of 3 plus, and let's go ahead and bring this one up too. So this is natural log of 0.4 squared, just to clean things up a little bit. All right, now on the left side, I have all x's here on the left. So let's do a little factoring. If I factor out an x from the left side, so this would be 2 times natural log of 3 minus natural log of 0.4. equals still on this side, I have natural log of 3 plus natural log of 0.4 squared. X is isolated, so I can divide out everything in my parentheses to solve for x. So this is natural log of 3 plus natural log of 0.4 squared, all divided. Let's rewrite this as 3 squared minus natural log of 0.4. So now we've worked it all down. So natural log of 3, all of that, if we were to punch that in our calculator, we'd get approximately a negative 0.236 is what the value of x has to be for those two to be equal to each other. Solving base E exponential equations. So if I had E raised to the x squared equaling 200, same thing, let's take the natural log of each side. Because I've taken the natural log, now this piece, if I were to bring this out front, x squared natural log of E equals natural log of 200. Let's just do a little side work here. Natural log of E. Well, we know natural log is really log base E. So it's saying log base E of E equals what? So it's saying E to what exponent equals E? Well, it has to equal 1. So this natural log of E, really, that's just 1. So that clears that up. We don't have to worry about that anymore. So all we're left with is x squared equals natural log of 200. We have an unknown that we are squaring. So it could be something, it could be a positive value or a negative value. So now that's when that plus minus comes in. Square root of natural log of 200 is equal to x. If I work that out, x would be approximately plus minus 2.302. All right, again, you have that unknown squared, so don't forget your plus minus. Do another one. E raised to the 2x plus 1 times e to the negative 4x equals 3e. Whenever we are multiplying with the same base, we can add our exponents. So this is e to the 2x plus 1 plus negative 4x equals 3e. 2x minus 4x is going to give us a negative 2x. Plus 1 stays. There is no common like term that we could simplify that with. So this becomes e to the negative 2x plus 1 times 3e. When I were to work this one out, so e to the negative 2x plus 1 equals 3e. I can go back and rewrite this using my idea of negative 2x, splitting these back up to say e to the negative or e to the positive first. So going in the opposite direction that we started out, I have a sum in my exponent. I can split it up and use the same base. Because these are being multiplied, so then I can divide by e, so I have e to the negative 2x equals now just 3. To solve this, I can take natural log of both sides. So natural log of e raised to the negative 2x, so that just becomes negative 2x, no longer in an exponent. Natural log of 3, divide by negative 2, divide by negative 2. So I have x equaling a negative 1/2 times natural log of 3, the same thing as natural log of 3 divided by negative 2, that's the same thing. If I were to evaluate that, x is then approximately negative 0.549. Now let's move on to solving log equations. So those were exponentials using natural logs to solve it. Well, we can also work with log equations and solve. So if I had 7 ln of x equals 28. So first thing I could do, this is multiplied, so I can divide by 7. So this is really natural log of x is going to be equal to 4. Natural log of x, really this is log base e of x equaling 4. Rewriting in exponential form, this says e to the 4th equals x. And that is exact. Let's just leave it as e to the 4th. Don't need to work that one out to a decimal. E, remember, is that constant 2.71, but we don't want to have a big long decimal. Let's just leave it as e to the 4th. That is exact. If we had this one with a base 2, so again, understanding what we're doing with exponentials, I could rewrite this with an exponential of a base 2 raised to the 3rd equals x cubed minus 19. 2 cubed is really 8, equaling x cubed minus 19. If I were to add 19, I would end up with x cubed equals 27. Right the other way, keep it in line. Now I can take the cube root of 27 equals x. I didn't need any plus minus because it only works for even value exponents. So if it was x squared, I wouldn't need the plus minus. X cubed, it's an odd exponent. I don't have to worry about that at all. Cube root of 27 is 3. So x is 3 for a final answer on this one. Now let's do one that's a little more involved. So log of x plus 6 minus log of x plus 2 equals log of x. So these are all log base 10. Going back to my properties of exponents, if I subtract with the same base, I can rewrite it as log of x plus 6 divided by x plus 2. I can write it as a single log. If I'm taking the log of something on the left and the log of something on the right, and it's the same base, I can essentially drop those logs, and it's just x plus 6 equaling x plus 2 equals x. Again, I want log of something to be equal to the log of something, so the somethings have to be the same. Now to solve x plus 6 over x plus 2 equals x, let's clear the fraction. Let's multiply this by x plus 2, this by x plus 2. So I've eliminated on the left. X plus 6 now is going to be equal to x squared plus 2x. If I were to subtract x and subtract 6 to set this equal to 0, I would have x squared plus x minus 6 is going to be equal to 0. So now I have a quadratic that I'm trying to solve. Again, I'm trying to solve for x. Let's do a quick cross. Is there a number that I could multiply to get negative 6 that adds up to be 1? Well, I could do 3 and negative 2. That will get me my 1, and they multiply to be negative 6. So this is really 0 equals x plus 3, x minus 2. So therefore, x is going to be negative 3 and a positive 2. So we got back to where we're working with quadratics to be able to solve. Now we have a product that we're taking the log of some product, and we want to have it equaling 3, and we want to solve. So this one looks messy, but it's really not that bad. Again, thinking back to our exponential form, log base 2 of something equals 3. So that means 2 cubed is going to be this 3x minus 7, x minus 4. I can FOIL those out. 2 cubed I know is 8. If I were to FOIL those, it's 3x squared minus 19x plus 28. Subtract 8 to set it equal to 0, so 3x squared minus 19x plus 20 now will be equal to 0. So again, this is one I can factor to try to figure out what the factors of this one are. So two numbers I multiply to get 60, but it adds up to be a negative 19. My two numbers that I could have that multiply to get 60, but add up to a negative 19 would be a negative 15 and a negative 4. So now I can do 4 spots. 3x squared minus 15x minus 4x plus 20. Break these into groups, add them up. I can factor out a 3x from this, and so this would be x minus 5. I know this one has to be x minus 5 as well. If I bring out my negative 4, then I'm going to have 3x minus 4, x minus 5 as my two values when I factor this. Solving for it, remember this all equals 0. X would have to be equal to a 4/3, and x would have to be equal to 5. Let's do another one. 3x plus 2, x minus 1, all equals 1. So again, this is a base of 10. If I am adding two logs with the same base, I can change that to multiplication. So this is log of 3x plus 2 times x minus 1 equals 1. Well, this was really log base 10, and so this is saying 10 to the first equals 3x plus 2 times x minus 1. If I were to FOIL on the right, I'd end up with 3x squared minus x minus 2 still all equals 10. So if I set this equal to 0, 3x squared minus x minus 12 is going to be equal to 0. So can I factor this one? Negative 12, that adds up to be a negative 1. 4 and 3 are numbers I can work with, but I can't get it to be a negative 1, or I'm sorry, not negative 12, because it's 3 times negative 12, so this would be a negative 36. So negative 36 to get negative 1, no, it's not factorable. So we have to go back. We can use quadratic formula to solve any of these. So if I use quadratic formula, x is going to be equal to our negative b plus minus square root b squared minus 4ac all over 2a. So in this case, it's going to be a negative of negative 1. So let's just say 1 plus minus negative 1 squared minus 4 times 3 times a negative 12 all over 6. So this ends up being 1 plus minus square root 145 all over 6. So what that's saying is I can have two possible solutions. I can say 1 plus square root of 145 over 6 and 1 minus square root of 145 over 6. But the 1 minus fails. So if we go back all the way up here to the beginning, if I were to do the log of 1 minus square root of 145 all over 6 minus 1, that leaves me with a negative in my parentheses. I cannot take the log of a negative value. So this one fails. This is my only true solution. You could check it in both of them and it works. All right, last one. Natural log of e to the natural log of x minus natural log x minus 3 natural log of 2. Well, on the left here, we already know this e to the natural log of x, that simply equals x. So I still have natural log, but e raised to the natural log of x simply just equals x. Minus my natural log of x minus 3 equals natural log of 2. Logs and natural logs share that same property. If I am subtracting, I can rewrite this as division. So this is x over x minus 3 equals natural log of 2. Because I'm doing the natural log on both sides, my unknown x over x minus 3 has to be 2. So I don't have to worry about natural logs anymore. I'm just trying to solve x over x minus 3 equals 2. If I clear the fraction, x minus 3, x minus 3. So x is going to be equal to 2x minus 6. If I were to solve from here, I can subtract x, so I have 0 equals x minus 6. So the only solution is x has to be equal to 6. All right, so I know that was a lot of example problems, but I want to get you a bunch so that you can work through the homework in Math Excel. It's not due till Sunday the 29th by midnight, but there'll be 2 additional lessons for this week that you need to work on. As always, email me with any questions, and we'll get through this.